All right, so this is 9.5 day 1 notes, complex numbers and Demoivre's theorem. 9.5 is actually just complex numbers. So first we're going to start off by plotting each one of these complex numbers. So if you look at this coordinate plane, it's not the normal x and y axis. We have a real axis and imaginary axis. So the x-axis that we're used to is really the real axis. The y-axis that we're used to is really the imaginary axis. So if you look at this complex number, an imaginary number here, it's in the form a plus bi, okay, where a is the real part and bi is the imaginary part. So we can graph this. This is telling us to go left 2 into the real parts. So that's this direction, right? And this is telling us to go up 3 into the imaginary direction, so that direction. So really, it's like plotting the point -2, 3. Go left 2, up 3, and there's your point. Same idea here. Right 6 into the reals, down 2 into the imaginaries. This one here, that's just a real number of 5, so we are not going up or down into the imaginaries. We're just going right 5. Think of this as like a number line right here, and you just went right 5 because it's a real number. This one here, down 3 into the imaginaries, there is no real part of that number. Okay, so this box here says, let z be equal to x plus yi or a plus bi. So you can use x and y or a and b, and that's going to be our complex number, our imaginary number. The magnitude or modulus, we use the word magnitude. Some books use modulus. That's why it says that. So the magnitude is denoted by, and this is the symbol for it right here. If you look, it looks like the absolute value of z, but it just means the magnitude of z. So the magnitude is defined as the distance from the origin to a point xy. So this should sound familiar because this is the same definition that we used in vectors, right? It was the distance from a point to the origin. So it says using the Pythagorean theorem, we can get the magnitude. So let's go ahead, and went ahead and graphed the real axis and the y-axis. So I'm going to say that my point is x plus yi. So I went right x and up y, and I got this point. Now, if we connect that point to the origin, this is our magnitude. So we can label that magnitude, and we'll call it of z. Now, if I said, all right, what's this distance right here? I went a little too far, but that distance right there, we know that's x. If I said, what's this distance right here? We know that's up y, so that's y, and I just made a right triangle. So if I said, how do I find the magnitude of z, or sorry, the length of z right now, which is the magnitude, I can use Pythagorean theorem. We can do leg squared plus leg squared equals hypotenuse squared. And then when I square root to get z by itself, or magnitude of z by itself, I get the magnitude of z is equal to the square root of x squared plus y squared. All right, so magnitude of z is equal to the square root of x squared plus y squared. Okay, so it says, since the magnitude is equal to the square root of x squared plus y squared, which is what we just got, and from our knowledge of polar coordinates, we know that r squared is equal to x squared plus y squared. So it follows that r must be equal to, if I solve this equation for r right here, square root both sides, I get r is equal to the square root of x squared plus y squared. So if both the magnitude of z and r are equal to the square root of x squared plus y squared, then the magnitude of z must be the same thing as r, which is true. All right, also, if we let a complex number z be equal to x plus yi, and from polars, we know that x is the same thing as what? R cosine of theta. Y is the same thing as r sine of theta. So if we take r cosine of theta and substitute for x right here, and we take r sine of theta and substitute in for y right here, we will get z is equal to r cosine of theta plus r sine of theta I. Okay, now this is the polar form of a complex number. This is rectangular form. This is kind of polar form. It's not exactly in polar form because we are going to clean it up. If you notice, both of these terms have an r in common, and the r is actually factored out. So let's factor out the r. So we have z equals r, and then factor it out. Nicer parentheses there. Cosine of theta plus, and then we actually write the I in front of sine, so it's I sine of theta. So this right here is the polar form of a complex number. R is the distance from the origin. Theta is the angle in standard position. All right, so we're going to write that. We're going to summarize what we just said to make sure we have it somewhere. So rectangular form of a complex number, okay, or an imaginary number, is z equals a plus bi or x plus yi. Polar form would be r times the quantity of cosine of theta plus I sine of theta. Okay, so those are the two forms that you need to know, and we're going to learn how to convert from one form to the other. All right, so it says on these directions, for example 1, plot each complex number and then write it in polar form. So I don't like that it says plot each complex number because that's actually how to write it in polar form. So the directions on your test and on your homework will say write the complex number in polar form. So if you look at this right now, this is in rectangular form. It's in the form x plus yi, okay? We need to convert it to polar form. So it has x and y. We need r and theta. So let's find r and theta, okay? So the first thing you're going to do is you're going to plot the complex number. So that's why the directions say that right there. So let's go ahead and do that. So this is left and up. So we're going to go left and up and make a point. It doesn't have to be accurate, like exactly negative root 3 over 3 over and up 3 over. You don't have to put tick marks. All right, so then what you're going to do is we need to find r. Okay, r is the distance. R is the same thing as the magnitude, which is the distance from the origin to that point. We are going to do that by making a right triangle right here. So here's my vertical piece, and I already have my horizontal piece drawn right here. We know this distance and this distance. We moved left 3 root 3, and we moved up 3. All right, so we need to find r first. Okay, so we're going to use the adjusted Pythagorean theorem. If you look right here, let me zoom out a little bit. We're going to use this right here. It's already solved for r to solve for r. Okay, it's just the Pythagorean theorem already solved for r. R equals the square root of negative 3 root 3 squared, x squared that is, plus y squared, 3 squared. All right, now we need to clean this up. R equals the square root of. I need to square negative 3 root 3. So what I want you to think of it as, let me go up here. This is negative 3 root 3 times negative 3 root 3. So when you're multiplying these two, you can multiply the number in front of the radicals, negative 3 times negative 3, which is 9, and then times. And then you can multiply the two radicals. Root 3 times root 3 is 3. 9 times 3 is 27. Another way of doing that, negative 3 root 3 squared, is to think of you're squaring this number, so you're multiplying it by itself. So multiply the negative 3 by itself, you get 9. Multiply the root 3 by itself, you get 3. 9 times 3 is 27. All right, so that's 27 plus, and then 3 squared is 9. 27 plus 9 is 36, so I have root 36. And then the square root of 36 is 6. Okay? All right, notice I'm not doing plus or minus because the square root was already there, right? It's the positive length. So 6 right here. All right, so we have r. Okay, so remember to write a a complex number in polar form, we need r and we need theta to put right here. So we have r right now. All right, now we need theta. So theta is this angle. Hold on, let me show you. This angle right here. Okay, that's theta in standard form from the positive x-axis counterclockwise. So what we can do is we can find alpha, which I'm going to call this angle right here. We can find that angle. And then knowing that angle, we can find this angle. Okay, so let's find alpha. Notice it says express the argument in radians, so we're going to put our answer in radians, not degrees. All right, so you can pick any two pieces that you want. You can pick the 3, the 6, or the negative root 3. I'm going to pick the 3 and the 6 because I don't want to pick a radical. So if I pick the 3 and the 6, this is opposite, this is hypotenuse, so I'm going to use sine. So we're going to say sine, I'll do it right over here, sine of alpha is equal to opposite, which is 3 over hypotenuse. Simplify it so you recognize it. Sine of alpha is equal to 1/2. So now we need to know our unit circle, right? So it says that I need to know the angle that has a sine of 1/2. Remember, sine is the y value. So that makes this root 3 over 2 1/2. And what's my ordered, that's my ordered pair. What's my angle that has that as an ordered pair? You're probably shouting 30 degrees. Remember, we want this in radians. 30 degrees in radians is pi over 6. So this is a pi over 6 reference angle. Okay? It's not, oh, pi over 6 is my answer. I'm not in the first quadrant, right? If you look, I'm in the second quadrant. So this will help me find theta, but theta is my pi over 6 in my second quadrant. If you remember your pi over 6 angles, they go pi over 6, 5 pi over 6, 7 pi over 6. I'm doing them in the wrong, I should put them where they are, right? So let me redo that. So we have pi over 6, and then 5 pi over 6, 7 pi over 6, and 11 pi over 6. I'm saying them, but I should write them in how they look in the quadrants. Since we're in the second quadrant, it's 5 pi over 6. All right, so now I can write my polar number, my polar imaginary number. It's r, which is 6, parentheses cosine of theta, which is 5 pi over 6, plus I sine of theta, which is 5 pi over 6. And there is your answer. Now, there is a shortcut way of writing your answer, which you are allowed to write your answer in. It's called Cis form. Cis comes from cosine, I sine. Okay, Cis form. So how you can write it is you can write your r value, and then cis, and then your theta value, 5 pi over 6. These two things mean the same exact thing. Okay, so either or of these is fine. All right, next one. We have 2 plus root 3i. That is a rectangular number. I need to convert it to polar. I have x and y. I need r and theta. So we are going to start by plotting this point. So write 2 up root 3 and say it's about there. Connect that, make it into a right triangle. So a lot of these things you should feel pretty comfortable with. This is 2, this is root 3. And then I need to find r right here. So let's find r using the Pythagorean theorem. Solve for r. So we have r equals the square root of x squared, which is 2 squared, plus y squared, which is root 3 squared. R equals the square root of 4 plus 3. R equals root 7. And root 7 is not simplifiable, so I'm just going to leave it as root 7. Erase that, root 7. All right, now I need to find theta. Theta is with positive x-axis counterclockwise until you hit your terminal side. So if you look, this is theta, right? Okay, this was theta in this problem, but this is actually theta right here. So I can just call it theta. I don't have to call it alpha. All right, pick whatever two sides you want. There is a radical no matter what, so I'm just going to pick the root 3. So that's opposite, and then definitely the 2, that's adjacent. So I'm using tangent this time. So I'm going to do tangent of theta is equal to opposite, which is root 3, over adjacent, which is 2. Now, if that was sine or cosine, I'd know it by heart, but I don't. So that's why this problem says use a calculator. So now we're going to use a calculator to figure out what theta is by using tangent inverse of root 3 over 2. This will give us theta. We can round to the nearest thousandth. It doesn't say that, but as I've told you before, when it doesn't give us directions, 3 decimal places is where you go. All right, so first off, it says in degrees. So the last one was in radians. This one's in degrees. You just got to pay attention to which one it is, which one they want. I want. All right, so let's look. Mode. I'm in degree mode. All right. So I'm going to do tangent inverse of root 3. Get out of my root. Divided by 2. And I have 40.893 degrees. All right, I have theta and I have r, so I can write this in either form. I'm going to do cis form, right? Root 7 cis 40.893 degrees. Okay? Or you can write it in the longer form, which is its standard form. Root 7 cosine, parentheses, I forgot, cosine of 40.893 degrees plus I sine of 40.893 degrees. These two answers are equivalent. It doesn't matter which one you write, but why wouldn't you write the second one, right? It's just easier. All right. Lastly, we have to convert we have to convert a complex number from polar form to rectangular form. And then there's some you tries. So you can pause the video, try them on your own, and then check back to see how you did. All right, so I have to convert to rectangular form. If you look, this is r cosine theta plus I sine theta. I'm given r and theta, and I need x and y. So this is actually pretty simple. What you're going to do is you are going to look to see if you know what this is. And you're going to look to see if you know what this is. If it's from the unit circle, you know it. 11 pi over 6 is something we have memorized from the unit circle, so I do know that. So I'm going to write 11 pi over 6 here, and I'm going to say what my ordered pair is so I can replace those two things with it. My sine and cosine is my two things. All right, so it's pi over 6 reference angle, so I know that's root 3 over 2 1/2. And then 11 pi over 6 is in my fourth quadrant, 1, 5, 7, 11. So if I'm in my fourth quadrant, I'm going right, which is positive, and down, which is negative. All right, so now what I'm going to do is I'm going to go ahead and replace the cosine and sine with those two values. So I have 4 times, instead of writing cosine of 11 pi over 6, I'm going to write root 3 over 2. It's positive, but I'm not going to put a plus sign. Plus I times, and then I'm going to replace sine with negative 1/2. All right, you're not going to leave your answer like this because you want it to look like this, okay? So in order to do that, I got to distribute. So I'm going to distribute the 4 to the root 3 over 2. So I'm going to do 4 times root 3, which is 4 root 3, and then I got to divide it by 2. So 4 divided by 2 is 2, so this is 2 root 3. Now I'm going to distribute my 4. 4 times negative 1 is negative 4. Divided by 2 is negative 2. So this is minus 2i. If you didn't catch where that minus 2i came from, once again, it's 4 times negative 1 divided by 2, and then times I. This is multiplying right here. Okay? Easy, right? All right, let's look at the next one right here. So I need to know if I know cosine of pi over 24, which I do not. Hence why this one says use a calculator. So you're not going to see what cosine of pi over 24 is first. Why don't you just distribute? You're going to end up distributing this 3, and since we're using our calculator, just distribute your 3 right now. Same idea. I could have distributed my 4 first here and said, all right, I have 4 cosine 11 pi over 6, 4 sine of 11 pi over 6i, and then replaced it. All right, so we're doing 3 times cosine of pi divided by 24. Oops. Round to the nearest thousandth again. And I get 2.999. Okay, not 999. All right, 3 times cosine of pi divided by 24. And I get 2.999. How come I didn't get that on my answer key? Let's try the other one. Sine of pi divided by, oops, I forgot the 3. 3 sine of, oh, I know why. I know why, silly. Look at what this is right here. This is a radian. I never changed my calculator back to radian mode. So it says use a calculator, but make sure you write the note radian mode. Now, unfortunately, I would not have noticed I would have noticed at some point, but if I wasn't looking at my key to realize that number was wrong. Hopefully I would have remembered when I went to go get sine. Okay, so let's change our mode to radian mode. Hit enter. And now retype that, and you get, see, it's like so close too, by chance, by coincidence there. So I get 2.974 plus, oh, it might be minus, hold on, And then I'm going to do 3 times sine of pi divided by 24. And I get plus 0.392 I. Don't forget about the I right here. And there it is in rectangular form. So this I just distributed. Okay, so the last two are U tries. Let's do the one that, you can do them in either order. And I'll do the first one in case you're doing them in the right order. All right, pause the video, try it on your own. All right, this is rectangular form. I need it in polar form, so I need r in theta, so I need to draw this to get r in theta. So this tells me to go left 2, up 2, make a point, connect it to the origin, make a vertical line. The horizontal line's already there. This is left 2, up 2. Solve for r using the Pythagorean theorem. Already solved for r, so the modified Pythagorean theorem. Negative 2 squared plus 2 squared. R equals square root of 4 plus 4. R equals root 8, so R is 2 root 2. There is a faster way of getting 2 root 2. If you recall from integrated geometry, this is a 45, 45, 90 triangle because it has 2 congruent sides, there's 2 congruent angles. When you have a triangle like that, your sides are W, W, W root 2. So if this is 2, 2, this is going to be 2 root 2. It's just a faster way of getting it so you don't have to use that modified Pythagorean theorem. All right, now I need theta. Remember, theta is this angle right here, okay? So I'm going to get this other angle in the triangle first, alpha, and then that'll help me figure out theta. All right, so remember you can pick any 2 pieces that you want. I'm picking these 2 because they don't have a radical. That's opposite and adjacent. So I'm going to do tangent of alpha is equal to opposite, which is 2, over adjacent, which is negative 2. So this is telling me I need to know the angles with a tangent of negative 1, okay? So you could just pretend, you could say, let's do it this way. What type of reference angle it is, because that's what alpha is finding, is the type of reference angle. So what's the angle that has a tangent of 1 in the first quadrant? 45 degrees, which is radians, pi over 4 radians. So reference angle is pi over 4. We're in our second quadrant, so that's going to tell us what theta is. So remember our pi over 4 angles go pi over 4. Odds, so 3 pi over 4, 5 pi over 4, 7 pi over 4. So in my second quadrant, I have 3 pi over 4. And now I can write my polar number, my polar complex number. You can write it in Cis form or the long way. So the long way is 2 root 2 cosine of 3 pi over 4 plus I sine of 3 pi over 4. That's the long way of writing it. Or you can write it in Cis form. 2 root 2 cis 3 pi over 4. All right, last but not least, convert to rectangular form. This is in degrees this time, but I don't need a calculator because it's 150 degrees. I know the ordered pair for 150 degrees. It's a 30-degree reference angle, so that's root 3 over 2 1/2. And then 150 is in the second quadrant, so it's left and up. So now I can do 2 times, replace cosine of 150 with negative root 3 over 2, plus I times replace sine of 150 with 1/2. Distribute your 2. 2 times negative root 3 is negative 2 root 3. Divided by 2, the 2's cancel, and I just get negative root 3. Distribute your 2. 2 times 1 is 2. Divided by 2 is 1. So I have plus 1. Don't forget about your I. So I have negative root 3 plus I. All right, that's it for 9.5 day 1. You can go ahead and get started.